We're going to first talk about congruence. So there is no vocab sheet this chapter, even though there's a couple vocab words. We won't get a vocab sheet or worry about a vocab quiz. So, all right, we're going to keep going along with transformations and translations and all that from last chapter, because that way we can talk about things being congruent and why they are congruent. So, here's a couple rigid motions. The first thing is we reflected across the line x equals -1. Then we went 2 to the right and 5 down to down here. Are these figures congruent? Are they the same shape and same size? And the answer is yes, they are. They are going to be the same shape, same size. This IH is the same as BC. They're both 1. IJ and CD are both the same. They're both 1. KJ and DE are the same. They're both 2. KL, EF are both the same. They're both 2. AF, LG are both 3. BA and HG are both 3. And every angle in here is a right angle. Okay? So they are congruent to each other. So we say that figure A, B, C, D, E, F, lots of letters there. A, B, C, D, E, F is congruent too. You just don't go in alphabetical order. You got to match the same parts to the same parts. Now, A starts in this part. This looks like Utah, right? Southwest corner of Utah, right there. Southwest corner of Utah. If you flip it over, A matches to that one, which matches to this one. So you start with G, and then you go H, I, K, L. And yes, they were in alphabetical order, both of them, but it doesn't always have to be that way. You got to match corresponding part to corresponding part, and that's what a lot of this chapter is about. A matches to G, B matches to H, C matches to I, E matches to K, and F matches to L. Ooh, I forgot a letter, J in there. D and J match to each other. Okay? All right. So you must get the letters in order. Okay? So two figures are congruent if their rigid motion maps one onto the other. So if they map onto each other, they are congruent. And so you don't have to write down the word congruent, because we all know that congruent means all sides, all the angles are the same. A rigid motion is sometimes called a congruence transformation because it maps to a congruent figure. So since everything in ABCD is congruent to DEF, and A corresponds to D, B corresponds to E, and C corresponds to F, and the corresponding sides are all congruent, then ABC is congruent to DEF. Whoops. All right. Does XYZ look like it maps to ABC? Does XYZ look like it maps to ABC? And the answer is, yep, sure does. First, if we flip it across the y-axis, if we reflect it across the y-axis, Z would map right here. Z would be there. X would be over here. And Y would be right up here. That's flipping across the y-axis. Then we should translate it one this way, which is -1, 0. So it's there, there, and there. And finally, we would flip it down across the line. We'd reflect it across the line, y equals 2. Okay? And then they would be on top of each other. That would be a composition of rigid motions that would get us there. Okay? Easier composition of rigid motions to get from there to there. It's just a translation of what and what. How do I get from red to blue? I go how far to the right? 1 to the right, and how far down? 4 down. So we go 1, -4. Okay? Then you'll be asked, which of these are congruent? Okay, so this is where you start counting squares. Okay? Counting squares. How do I get from A to B? I go up 1, 2, 3, 4, and to the right 1. So AB, I go up 4 and to the right 1. So any of these do I go up 4 and to the right 1? LK, JK, or JL? Any of those I go 4 and 1? Well, JK, I go -1 up 4. Whoops, I did this backwards. Probably I should go 1, 4 in that order. So JK, I go -1, 4, which is the same length. Okay? Any of these that I go 1, 4 in? No. This one's not going to be congruent. Okay? Because if it doesn't match the sides of the triangle doing the same things, it's not going to match. This one I go 3 to the right, up 1. This one I go 3 to the right, down 1. That works. This I go over 4 and up 5. This one I go back 4 and up 5, or else to the right 4 and down 5. As long as all the numbers match, the signs don't have to match, but as long as all the numbers match, these two are congruent. So, what side would A be congruent to? Or what angle would A down here be congruent to? J. Because it's in between the 1, 4 and the 4, 5. In between the 1, 4 and the 4, 5 is J. Then B is in between the 1, 4 and 3, 1. So it would be K and then L. Okay? Do these two look congruent? Sure do. They do look congruent. So, are these congruent? The answer is yes, because all the sides do the same thing. So, yes, they are congruent. All right. Now, a bolt builder plans to connect two pieces of wood by using the puzzle joint as shown. For a successful joint, each unit must be congruent. Given unit A, what's composition of rigid motions to map unit A to unit B? What maps this down to this? It's just a straight translation. Just a straight translation. Okay, so congruent figures are a mapping of some sort. It might be a reflection, translation, rotation, or a combination of them. Okay? So your first assignment will deal with basically what we were dealing with last chapter: translations, rotations, reflections, figuring out if things are congruent.